LiDAR and surround vision are still necessary technologies for a higher level of automation as we increase the operational domain of radars. Aptiv proposes a radar-centric approach. If you rely completely on vision, you are blinded by glare, you're blinded by sundown effects. Then you have issues like fog or dirt on the streets and even dust, which can completely block the vision. And radar, by design, has not this issue. This is a completely new approach. It's basing upon deep learning methods. Neural networks offer the opportunity to leverage data in a much better way. So the main differentiators between radar with machine learning and classical methods is that it is a complete data-driven approach. The more data you put into the system, the better it gets. We use data for training and we leverage that data to make the algorithm learn out of it. We are able to squeeze out much more information out of the radar low-level data and to use it better than in classical methods. That means we are able to do things with radars which were not possible before. So in this video you can see a test drive on the Las Vegas Boulevard taken during 2022 CES with our live demo vehicle. You can observe the radar machine learning only perception visualized with boxes in green, driving vehicles turning orange when they stop. And here on the right side you can see a group of pedestrians walking behind a concrete wall, and the radar is still able to detect them. This shows the high recall also in cluttered scenarios. There's no false positives. Another detail I would like to highlight in the same scene is the orange surface coloring, which shows segmented area. As the Las Vegas Strip is a dual carriageway and you can easily see the medial strip which separates the driving directions from each other, which is of course relevant for driving decisions. In this example you can clearly distinguish the driving path and the street area from the concrete wall to the pedestrians, trees and buildings. This demonstrator is able to show radar recognition live. The ego vehicle is not moving and the pedestrians are very slowly moving. Still, we can show a stable detection on the pedestrians, as you can see. We can also classify other objects like bikes. So my colleague is riding his bike in front of the vehicle and you can see a green box instead of a red one. This enables features in the urban area in which pedestrian positions and bikes need to be monitored constantly 360 degrees around the vehicle. It is not enough to find the most powerful algorithm as we live in the automotive world, where we cannot rely on cloud compute and huge number crunchers. The data is generated in the sensor head, which does basic signal processing up to a level where Ethernet bandwidth is possible. Then the data is transported into a data power center and routed further into the central device which hosts the machine learning accelerator. The good news is, we have been working on the realization on compute hardware in the past years already, hand in hand with algorithm development. We have created IP in areas which can be used especially for our algorithms, but also for other machine learning areas. Our concept how to implement our machine learning efficiently is also an outstanding capability Aptiv offers.